Now let us see how to define the molar specific heats of solids. So here I do not call it at constant volume or constant pressure, because so when the solid is heated it expands, but it expands so little that it is the work done by it is negligibly small. So we neglect that thing. So now in a lattice, let us see the energy of the atoms when they are in the form of lattice. In gas they are free, but in a lattice, crystal lattice, suppose this is a cubic lattice system. This is the cubic lattice system, and you can see here so just imagine this system. So we have here one cube, one cube, one cube, and here. So just imagine this atom here. This atom is free to oscillate along this direction. It is again free to do the same thing in this direction and this direction, because here neighboring atoms are there. So these are the neighboring atoms. So they interact with them, so they can interact with them in this. So we have three directions. So each atom in a solid lattice can have oscillatory motion along the three directions, i.e. along A, B and C, that is the lattice parameters A, B and C. So there are three different directions along which they can have, thus they possess three kinetic energy terms and three potential energy terms. So each degree of freedom is associated with each quadratic term, whether it is kinetic or potential. Thus each atom, we can have molecule also, each atom will have 6 degrees of freedom. We have 6 degrees of freedom, thus 3 kinetic energy terms and 3 potential energy terms. So total 6 degrees of freedom for each atom present at the lattice point, because they have 3 independent directions of oscillations. Thus the internal energy delta U expression, which we write that total number of atoms N into the degrees of freedom F into half kT amount of energy, that comes out to be N into Avogadro number Na, that is degrees of freedom F by 2, K means R by Na again into T. So you see this is, let us write is as delta T, because change in temperature, change in internal energy, let us write Na cancel, we have N number of moles into degrees of freedom F, that is 6 by 2 is equal to 3 N R delta T. This is what delta U is for a solid. You see, I have taken this solid as any solid, gold, iron, silver, any solid, this expression will be nearly valid. So we define this C for that solid as 1 by N, this is molar. So that is delta Q by delta T, that is again 1 by N, since delta Q is equal to change in internal energy delta U will become 3 nr delta T by delta T, nr delta T. So, delta T cancels out, Nn cancelled out, we have 3 R. Thus, the specific heat of a solid becomes 3 R, which is nearly constant for all the solids.